All right, video 6.2. 6.2 is not the easiest lesson we will have this year, to say the least, but here we go. All right, so the first one, we use a question from the El Dorado Community College, and it has the number for full-time students. It does say full-time students. We have up here, this is the probability model for how many, instead of saying semester hours, they're calling them units. All right, so we want the expected value. Now, to do this problem, I would plug it in my calculator. So stat edit, and I went ahead and already plugged those in. And then I go stat calc 1var stats. Remember, we need frequency list to be L2 in this situation. And I go down and hit enter, and that's how I get, hit my camera holder. So I get 14.65 and 2.056 units for the standard deviation. And then I go back, fill in the work. But the College Board actually will let us do 2 steps to establish a pattern. Although I can see I don't have plus ... We're going to fix that one real quick. So you only need one of these 2 statements, these 2 pieces here, but either one is fine. So you can do E of X or mu of X. It does not matter. And then 12 times 25%, 13 times 10% plus ... And then there's my answer. That's the easiest, shortest way to do that. Okay, and then interpret. If we do many random selections of U.S. and really, I'm sorry, it's not U.S. El Dorado Country Club, community college students, we expect the average number of units to be about 14.65. And really, to be honest with you, context, full-time students would be better here, but we're not gonna worry about that too much. But I really should have full-time students there, and you should try to get used to writing it down better. All right, then the next one for the standard deviation, you still have the same 12 and 25%. You still have the same 13 and 10%, but you subtract the mean. Because remember, standard deviation is how far do we expect to be any one random selection, how far away from the mean? Well, you have to subtract the mean to make that happen, square it to make it variances, multiply by the probability that it happens, and then add them all up together. But again, we can get away with 2 steps if we do plus ... And make sure that plus ... is inside of the square root. This probably should not be, but there you go. But that needs to be under the square root. That'll happen, unfortunately, quite a bit. If I randomly select a student from El Dorado Community College, the number of units will typically be off by 2.056 from the mean, which the mean was 14.65. So the average, if I take one person, I expect on average the gap to be off by 2.05. And there you go. Now it will absolutely be on your FRQ test, so be ready for that. So it'll ask you to calculate and interpret mean and standard deviation. If you're ready for it, the calculator tells you the answers. You learn to backfill in the work, and you interpret it correctly, and you should be in good shape on that one. But there'll be a lot of people that do poorly on that one. So anyway, the next one says, well, now instead, what if we did it by tuition cost? And tuition cost is 50 cents per unit of class time taken, which is low, but this is kind of an old problem. And it's a community college in Arizona, so they're going to be less there anyway. All right, so then what we did was they took 12 times 50, 13 times 50, 14 times 50, and so on. Okay, and then I do the problem. I plug this in my calculator. I get these 2 answers. Then I backfill in the work, and there it is. And then also, I'd like to point out that 14.65, this average is 50 times that is this average. The standard deviation of 2.056 times 50 is 102.80. So that works out. If I multiply the original data values, not just multiplying stuff, but I take the original data, I multiply the original data times 50, what happens to the mean and the standard deviation? And the answer is they're also both multiplied by 50, just like we would want it to. When we add, it does not work out that way. All right, so when we add, it does not change spread. So spread is how far away all the points are from the mean. If every single point has been added to, it does not change how it's spread out. So that one, this next one says, oh yeah, in addition to $50 per unit, there's a $100 lab fee for computers, or maybe there's a fee of $100 per semester. So they go through and add 100. So what's that do? It adds 100 this was the mean of just the tuition. This is the tuition plus the lab fees. This is the standard deviation. It does not change because adding an amount does not change the spread. And then here it is in equation form, but most of us don't like equation. This is the absolute value of B. But see how there's no plus or minus A? Because adding or subtracting a set amount will not affect standard deviation. All right, then here's an actual question. Here we have that the teacher, in order to go from the raw score to the hack score, if you will, they give us the mean and standard deviation of the raw scores. And then to get their grade, we're going to take it times 4 and then add 10. So we take the score that they got, we multiply it by 4, and then we add 10 to get the scaled score. So y is the scaled score. Okay, and then mu of y is you take the old mu times 4 plus 10 to get the new mu. Mu works out just the way we want it to. Just you take it times 4 plus 10. The standard deviation, we do not add the 10. So the standard deviation for the raw score was 3.8, but because we multiplied the raw score times 4, that's going to increase the standard deviation, but the plus 10 doesn't. So we had our old mu and sigma up here. Now we have new mu and sigma, which we use for the calculations. And I know this looks a little different than the notes we did in class, but there was some mistakes, so I redid some of it. Not all of it. As you could tell, I missed a few things, but some stuff has been cleaned up a little bit. So then y file, you got to state the distribution. We have already got y defined here. This isn't a very good definition, but for right now, it's good enough. And then solve it out, right? Answer the question with context. Remember, normal CDF is the second VARS, but I'm not going to spend time with that. We should know how to do that by now. And if you don't, you need to come to class and ask. Okay, this one's a little bit cleaner version than the one we had in class also, if you already was here, but this one we defined M and F. It really was kind of defined up here, so I didn't do that in class the other day, but it's probably better to have it defined out. And then I'm going to also do D is M minus F, and I've made this variable D. So mu of D is equal to mu of M minus mu of F, 4.5. It's just that simple. So if I'm finding the difference between the averages, is it the difference of the average? I mean, can I just subtract them and it works out just right? And the answer is yes. Mu is nice. Sigma, not so much. So first of all, remember, in order to combine standard deviations, you must first convert it to a variance. You convert it to variance by squaring it. And then you take it back by square rooting. So make sure you get a square root in there. And then the male standard deviation was 4. The female's was 3. Also, I add. I do not ever subtract variances. You can't subtract. Now, also, if I had done this, but I did the other direction, I'd had 3 squared minus 4 squared, which would have been a negative and undefined. So you can't subtract because then the order matters. But when you square them and add them, it's the same. And then we want to know the probability that the male was taller. So up here where I have my D is M minus F, this I know D needs to be greater than 0, because if the male is taller than the female, then that means D is going to be positive. So I want D to be positive, and then I do my normal CDF, and I get a percentage, and there you go. And that's it. And this will be a FRQ question on our test. There'll be different things, but the overall game plan is the same. There'll be two different things. We're going to get our new mu and new sigma. We're going to subtract to get the new mu, just like we want to, and we're going to establish the order up here to make it easier on ourselves. Sigma is going to be the 2 standard deviations squared plus each other, not minus. And then we use that new mu and sigma, the 4.5 and the 5 right here, to actually do the normal CDF. But on this question, we got to be mindful about which direction this is pointing and the fact that that one is 0. All right. So this down here is not on the notes for the year I'm recording this video, but I'm going to go ahead and go through it because I'm hoping next year to not print the wrong packet. So I'm going to still go ahead and go through it. But These two right here, with this one we're going to talk about first. So this is what I call a combining problem. So it's you're going to be combining usually more than one thing, but it could only be two things, but usually it's more than one. So they tell us that the weight of an apple is 9 ounces with a standard deviation of 1.5. What about 12 apples? So W is the weight of one apple. That's my old mu and sigma, but I need my new mu and sigma. So T is the total weight of the 12 apples. Okay, so old mu and sigma right there, but I need new mu and sigma. So the new mu is nice. It's on average, they weigh 9. I'm getting 12 of them. On average, they weigh 108, just like we want it to be. But for standard deviation, we're actually doing 1.5 squared 12 times because we're combining these together as two separate entities. You can't just take it times 12. I really wish you could. I wish you could just do 5 times 12, but it does not work out that way. You can see it's quite a bit smaller than 5 times 12. So anyway, so what happens here is we take 1.5 squared plus 1.5 squared plus 1.5 squared 12 total times. Or I can do 1.5 squared times 12 and then square root it. That's going to be way easier to get on the calculator, way easier. And then the probability that the 12 apples weigh less than 100 ounces, that's my normal CDF, nothing fancy about it. Except again, I have my new mu and sigma that I had to solve here. So the hard part is getting the new mu and sigma. All right, and then for this last one, so you can, if you don't have this on the notes the year that you're watching this video, I apologize, you'll just have to look, and it can still be helpful to you. So this one is cars sold versus cars leased. And they wanted to find out what's the chances that we sold more cars than we leased. So, and they give us mu and sigma on these, so I don't have to go solving those out by hand, which is kind of nice. So the mu of the difference, and right here, see, difference is x minus y. So mu of x minus mu of y. So mu of x, 1.1 minus mu of y, 0.4. That's it. That's it. That's the average. If we find the difference of many pairs of randomly selected days of sales versus lease, we expect the average difference to be about 0.4 cars. Okay? It does say find and interpret. For this one, it just says compute. It doesn't want the interpretation. Anyhow, so on this one, I can take the standard deviation of the first one plus, the variance of the first one plus the variance of the second one, and then square root that to get the standard deviation. So that, again, sigma is not nice. Mu is nice, not sigma. All right, the dealership manager receives a $500 bonus for each car sold and $300 bonus for each leased. Find the mean and standard deviation of the difference in the manager's bonuses for the cars sold and leased. So the sales bonus was on average 1.1 cars sold times 500, 550. The average lease bonus is 0.7 cars sold times $300, 210. So mu of the difference, I subtract those. Okay, now on this one, for this problem, when we take the sigma of the sales, we take 500 times 0.93 because we have 500 times the standard deviation of the sales. And then it's because instead of one sale, it's $500 per sale. So it's like I'm multiplying each value in the X by 500 here and 300 here. So there's my two standard deviations. And then in order to combine those, I have to square them, turn into variances, then combine them, and then square root it back down to get standard deviation. And again, if you don't have that problem, you just don't worry about it. And or maybe you followed along, if not, it's all right. That'll be an in-class problem next year when I don't send off the wrong document to the Copy Center.